Good day, students. Welcome to math.surf.com. In this clip, we're going to be going over how to solve systems of inequalities by graphing. This is the systems of inequalities part of our virtual algebra text. Alright, the instructions for the example we're going to be working, the instructions are for us to graph the solution to the system of inequalities below. Alright, so let's say we have the system of inequalities. Y is greater than 1/3 x minus 2, and y is greater than or equal to negative 4/3 x plus 3. Alright, so we have a system of inequalities here. We're going to go ahead and solve it by graphing. Let's go ahead and rewrite the inequalities. Y is greater than 1/3 x minus 2, and y is greater than or equal to negative 4/3 x plus 3. So what we're going to do first is we're going to proceed to label both inequalities, and then we're going to graph both of them on the same coordinate system, and then the intersection of the regions that we get from the two inequalities will be our solution. Okay, so we're going to graph the first linear inequality in blue, and then the second one, let's graph that in red. Okay, so let's start with the first one. The first goal is to graph linear inequality 1. Linear inequality 1 is given by y is greater than 1/3 x minus 2. This inequality is presented to us in slope-intercept form. Do you recall what the slope-intercept form is? It is y equals mx plus b. The beauty of the slope-intercept form is that it helps us to easily identify the slope and y-intercept of any linear equation or inequality written in slope-intercept form. As you can see here, the slope is the coefficient of x, which is 1/3, and the y-intercept is negative 2. Let's go ahead and write that down. So our slope, which is m, is given by 1/3. So what does this mean in the context of the graph? It means that we're going to rise 1 unit up and run 3 units. Okay? So remember, slope is rise over run. So if you have the slope in fractional form, the numerator is your rise and the denominator is your run. So these are the movements from the starting point to the terminal point. That gives us the 2 points that define the line. Next, we have the y-intercept. The y-intercept is the b value. The b value, as you can see here, is negative 2. And this is basically where you start on the y-axis, okay? So think about b for begin. You begin at the point 0, negative 2 on the y-axis. Alright, so the y-intercept of negative 2 graphically is 0, negative 2. Now we have an inequality here, so the inequality is going to affect the appearance of the graph. So let's go ahead and take a look at that real quick. So the effects of that inequality greater than, there are going to be two effects of this inequality. The first one, since it's greater than, we're going to be shading above. Alright, and then the second effect is that since it's just greater, it means we're going to exclude the boundary line. How do we reflect the exclusion graphically? We illustrate that by breaking the line. So we're going to shade up, and the line is going to be broken line. Okay, so let's use this information to draw the graph of the first linear inequality. and then we'll proceed to the second one and we'll draw it on the same coordinate system. Alrighty, so there goes my axis, my y-axis, and that's the x-axis. So we start with the y-intercept. You begin with the y-intercept. The y-intercept is -2, so you graph 0, -2, or -2 on the y-axis. That's down here. Okay, and then we're going to rise 1. Using the movements now or the slope, you rise 1 and you run 1, 2. So run 1, 2, 3. Bam. So these are the 2 points that define the line. Okay, rise 1, run 3. We can put in more points. Rise 1, run 1, 2, 2, 3. There it goes again. Rise 1, run 1, 2, 3. Going backwards, if you want to graph points to the left of the axis, you drop 1 and back up 1, 2, 3. Just to have a collinear points. Drop 1, back up 1, 2, 3. Okay, when we are drawing the line, we want to make sure that the line is broken. Okay, so let's go ahead and graph the line. It's going to be a broken line. Let's not make it too thick now. Alright, let's draw the line. This is a solid line. We need a broken line. Bam. So that goes the graph of line 1. Okay. So put the arrow on the ends to indicate that they go on forever. So that put an arrow there. Alright, so that's the first inequality, but we are not only going to break it, we also have to shade, okay? So where are we going to shade? It's greater, so we're going to be shading above. But since we have a system, we're going to be looking at the intersection of shades. So what we're going to do in order to avoid making a mess on our coordinate system, we're just going to indicate the direction of the shading with an arrow for now, okay? So since it's greater, we're going to be shading above. So we're going to be shading above this line right here. Okay, so let's keep that in mind. We're going to go ahead and graph the second one, and then we'll look at where the resultant intersection region is. Alright, so let's graph number 2. We're going to put that one in red. So let's graph 2. The linear inequality for 2 is y is greater than or equal to negative 4/3 x plus 3. Okay, so this is also given to us in slope-intercept form, which is nice. So put y equals mx plus b underneath. We can clearly see what m and b are. M is negative 4/3 and b is 3. Okay. Alright, let's go ahead and write down the relevant information to help us graph the slope first. M is given by negative 4/3. So what does this tell us about the movement? You're going to rise negative 4, which is a fall. So you're going to fall negative 4, and you're going to run 3. Okay? Don't forget, these are your movements. Now, where do you start moving from? Well, that's what the y-intercept is for. The y-intercept, the b value is 3. Okay? So that means we're going to begin at the point 0, 3. That's the point representation of the y-intercept on the coordinate system. We have greater than or equal to. What does that tell us about the effects it will have on the graph? Effects are as follows. There are going to be 2 of them. The effects of greater than or equal to. First of all, it tells us that we're going to shade above the line. Okay. And secondly, since there's a line on the bottom of the inequality, this means it's a combination of greater than or equal. Okay. So it means the boundary point is included, so that means we're going to have a solid line. Okay. So just remember, greater than or less than, these two are broken because they do not have the line underneath. Greater than or equal to or less than or equal to, these two are solid because they have the line of inclusion underneath. Alright, we went over this point in our previous lesson on graphing linear inequalities. Hopefully you remember them. Okay, let's go ahead and graph the line. We're going to start with the y-intercept. The y-intercept is 3. So we start 1, 2, 3. We're going to rise -4. 1, 2, 3, 4. And we're going to run 3. Okay, so rise -4, 1, 2, 3, 4, run 1, 2, 3. Right there. Okay, you can do another point. Drop 4, rise -4, 1, 2, 3, 4, run 1, 2, 3. Bam, like that. Or you can rise 4, 1, 2, 3, 4, and back up 1, 2, 3. Alright, so we're going to make this line solid, and we are going to be shading above. Let's go ahead and graph that line. So it goes through this point, like that. Just extend this other end a little bit upwards. Alright, so this line we just graphed is y equals -4/3 x plus 3. But the inequality tells us that the greater than component has to be considered also. So to include that, the greater than component, we're going to shade above. Alright? But since we have a system, we're just going to point arrows like that. Alright, so there is a resultant region that we're going to shade. Think about this as four quadrants, okay? Let's look at it that way. Let's say we have quadrant 1, this entire quadrant here, quadrant 2, this entire quadrant right here, quadrant 3, and quadrant 4. The question is, where are we going to shade? The solution region is just going to be one quadrant. The quadrant we're going to shade is a quadrant where we have two arrows pointing inwards. Okay? The region where two arrows are pointing to is the region that we are going to shade. Let's take a look at quadrant 2, for example. Do we shade this region right here? The answer is no. Why? Only this arrow is pointing in that direction. This arrow is not pointing under it. This arrow says everything above, not below. So we cannot shade that region. Can we shade quadrant 3? Think about it for a second. The answer is no. Why? Because this arrow points above and this arrow points above, which tells us that any region below these two lines is not part of the solution region. So we cannot shade 3. How about 4? Is this the solution region that we are looking for? The answer is no. Why? Because the red arrow is pointing towards it, but the blue arrow says no way. Any region above this line is good, but below. Region 4 is below the line, hence it is not a solution region. Okay? So now let's take a look at region number 1. Well, that is the region that we're looking for. That is the solution region. Now, why is region 1 the solution region? If you look at the two arrows, the red and the blue, they are both pointing in that region. So, region number 1 is our solution region. So, we can just use lines to shade it however way you want to shade it. This entire region is a solution. What does this mean? This basically means that any point that falls inside this shaded region and on the red line above the blue broken line, any point in that that meets that requirement will satisfy the system of inequalities that we have. Alright, so this region we just shaded right here, that is the solution region. Solution region. So the question is, how many solutions are there? The answer is there are infinitely many solutions because a lot of points. There are infinitely many points in this region right here. Alright, so how well did you understand the contents of this presentation? To ensure mastery, we'd like you to try out the following problems. So try these out. So instructions are the same as the initial. You're to graph the solution to the system of inequalities below. Okay. Alright, so let's consider two examples for you to try out. Number one, or two exercises. What if you have y is less than negative 4x minus 3 and y is greater than or equal to 2x plus 3? Number two, what if you have y is less than negative x plus 3 and y is greater than 2x minus 3? Alright, we'll give you the opportunity to pause this video presentation, try out these two problems. When you're done, click back on the play button to see what the answers are. Alrighty, so there goes the solution to the graphical solution to the system of inequalities. This is for question number 1, and this is for question number 2. Okay, if you have any questions about how these answers came about, feel free to post it in the comment section below, and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial helpful in your studies of graphing, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions or comments, as indicated earlier, just post it in the comment section below, and we'll be glad to assist. Do subscribe to our channel for updates to other tutorials such as this. More support resources can be accessed at mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.